Welcome to the Orpheus ROV, a capstone project. Orpheus is named after a character in Greek mythology, who goes to the underworld. The Orpheus ROV is a fully network-controlled ROV that can go deep as 100 feet underwater. Its several sensors detect water pressure, depth, temperature, calculate orientation using compass and gyroscope, and has a built-in data logger to save information for later review. This schematic shows the whole of the ROV. It's divided between a base station, where the controller can monitor and maneuver the rover, and the rover body itself. Both the rover and the base station are connected together by Cat6 Ethernet cable and DC power lines. The Cat6 cable does the communication and video feed, and the power lines provide power for the different voltages required for the ROV, ranging from 12, 36, and 5 volts. Let's take a closer look at the base station. Power is converted from a wall outlet of 120 volts AC to 48 volts DC by a converter, which sends the current to a safety fuse, and then routed to a safety switch. The switch key needs to be turned on for current to flow to the ROV. Once the switch is turned, current goes to a digital ammeter that gives its value to a microprocessor, an Arduino, which gives out current usage in analog and digital output. In our ROV, to go forward, 4 motors positioned at 45 degrees needs to provide forward thrust. This technique can be explained using vectors. This is why the motors are mounted at 45-degree angle from the side of the ROV. Now let's look at the ROV itself. Once power and data enters the ROV, the 48 volts gets distributed to 48 to 12 volt converters. One module powers the motors, and the other module powers the LED lights and components like the Cisco switch and other peripherals. The Ethernet cable connects to the Cisco switch, which connects the base station, Arduino DUO, Raspberry Pi, and an HDMI to IP converter in a single network. Data packets can easily flow between these components. The joystick sends its position information of its 12 buttons and 5 axes of movements to the Arduino. Arduino parses and interprets the data and sends the information to the motors and lights. Similarly, Arduino sends the sensor data back to the base station to be displayed and stored into a database. Here is the demo of the system working for the first time. And here is the latest demonstration of the system. we created our own 3D model in SolidWorks. The first iteration had to be modified for vertical length. Each model takes approximately 4 hours to print. "3D printing works by placing layer upon layer, and our model has a layer height of 10 tau or 0.25 mm per layer. The final 3D printing of all the parts took 34 hours to complete.